Role of theoretical plate in chromatography analysis. In this session, you will learn what is the theoretical plate, what is its role in chromatography analysis, what are the different formula for calculating theoretical plate, which formula is best for calculating theoretical plate, what are the factors affecting theoretical plate, what are the advantages of theoretical plate. Namaste and welcome to Pharma Knowledge Forum. My name is Dr. Pramod Kumar Pandey. I provide a skill-based lecture on pharma analytical techniques like analytical method development, analytical validation, impurity control strategy, genotoxicity, chiral separation, managing deficiency letters. Fees for such lectures are much less than you expect. Only thing is that you have to subscribe the channel and like the video. Theoretical plate, it is also called column efficiency. It is denoted by N. N is one of the widely used system suitability parameter used in the chromatography analysis. It tells about the sharpness of the peak. See, in sample mixture 1, all the peaks are sharp, whereas in sample mixture 2, all the peaks are broad. Now question is how n will be calculated. I am going to discuss in next slide. The following formulas are used to calculate the theoretical plate. N is equal to 16 into T divided by W whole square. This is a formula 1 where T is equal to retention time of the peak, W is equal to width of the peak at half height. N is equal to 5.45 T divided by W whole square. This is the formula 2 where T is equal to retention time of the peak, W is equal to width of the peak at half height. N is equal to 4 into T divided by W whole square. Now question is which one is the best? In industries, especially in pharmaceutical industries, Formula 1 and Formula 2 is used, and in which case Formula 1 will be used and in which case Formula 2 will be used. It depends upon the nature and shape of the peak, and the same I am going to discuss in next slide. Formula 1 is used for symmetrical and sharp peak. Formula 2 is used for unsymmetrical and broad peak. In this chromatogram, all the 5 peaks are sharp, and hence while developing the method, Formula 1 should be used for calculating the theoretical plate. In this chromatogram, all the 3 peaks are broad, and hence Formula 2 should be used for calculating the theoretical plate. The higher the theoretical plate, more sharper the peak, means more peaks can be separated in single run. Broader the peak, several components cannot be separated in a single run. Factors affecting theoretical plate: temperature. On increasing temperature, peak sharpness is increased and hence theoretical plate is increased. On decreasing temperature, peak broadness is increased and hence theoretical plate is decreased. Retention time. Theoretical plate is directly proportional to retention time. Therefore, on increasing retention time, theoretical plate is increased. Width of the peak. Theoretical plate is inversely proportional to width of the peak, and hence on increasing width of the peak, theoretical plate is decreased, whereas on decreasing width of the peak, theoretical plate is increased. Buffer concentration. On increasing buffer concentration, peak sharpness is increased, and hence theoretical plate is increased, whereas on decreasing buffer concentration, peak sharpness is decreased, and hence theoretical plate is decreased. pH. Some of the compounds are highly sensitive to pH. At a particular pH, that compound gives sharp peak. Therefore, theoretical plate also depends upon the pH. Peak tailing. On increasing peak tailing, theoretical plate is decreased, whereas on decreasing peak tailing, theoretical plate is increased. Injection volume or sample concentration. On increasing sample concentration, theoretical plate is decreased, whereas on decreasing sample concentration, theoretical plate is increased. Mobile phase viscosity. On increasing mobile phase viscosity, theoretical plate is decreased, whereas on decreasing mobile phase viscosity, theoretical plate is increased. Column length. On increasing column length, retention time is increased, therefore theoretical plate is increased. Peak shape. On increasing sharpness of the peak, theoretical plate is increased. Particle size. Theoretical plate is inversely proportional to size of the stationary phase. Therefore, on decreasing particle size, theoretical plate is increased, whereas on increasing particle size, theoretical plate is decreased. That is all about this session. I hope you have enjoyed the session. One important message for you: if you want to make career in pharma analytical research or quality control, then you can join my advanced courses. Details you can find in the description. Thank you.